Welcome everybody to video 3. I hope the other 2 videos are helpful. I'm going to try and continue breaking down the videos a little bit more into individual parts and more easy to digest parts. And so for video 3, we are going to revisit the unit circle, starting with looking at the terminal points on the unit circle. So what I mean by terminal points is as we travel around the circle, and I'll draw this here. The spoke, as I go around, will always intersect the circle at a specific point. So for example, if I'm staying in the first quadrant, which is what my plan is right now, so I'll do it about right here. This intersects the circle at a specific point. And if this is in a graphing coordinate, then I could describe this terminal point right here with an X and Y coordinate. And so our goal today is to figure out, okay, well, what's the connection, or making all of the connections now from what we've been doing into locating what this point is and what it implies and what we can do with it. And so when I have in focus in this first part on just the first quadrant, we know that my radius is 1 because this is a unit circle. And also, I know based on how the coordinate system works that this distance here is x and this distance here is y. And if you notice, this overall shape is a right triangle. Specifically, this right triangle and this ordered pair is formed when I rotate or travel around the circle theta angles either in degrees or in radians. And so from here, we can actually establish then a relationship between x and y and the angle that we're going using the trigonometric ratios that we talked about in the previous video. So, for example, if I wanted to know what is sine theta for this angle, well, sine theta would be y over 1, or just y. Cosine of theta would be x over 1, or just x. Tangent theta would be y over x. And so we have this established relationship then in terms of my coordinates. And so this is a property we know then for the other 3 that if we needed cosecant, this would be 1 over y, the flip. Secant, oops, that was a terrible, there we go, would be 1 over x, and cotangent would be x over y. And so we have these relationships. Now, in terms of what we're going to focus on, at least in the next couple of pieces, I'm really just going to worry about the big 3 and primarily just sine and cosine, because notice that sine and cosine actually describe x and y on the dot. And so that's kind of what we're going to be looking for essentially. Sine is associated with the y value, cosine is associated with the x. All right, and so before we kind of continue, again, I'm focusing on just the first quadrant, and the angles in the first quadrant, those special angles, where the angles are in between 0 and 90 degrees, or 0 to pi over 2, is 30 degrees, 45 degrees, and 60 degrees. Dang it. I forgot to turn my notifications off. There we go. All right, so now we won't be interrupted. Okay, so and 30 degrees, 45 degrees, and 60 degrees. And so what I want to do is I'm going to draw each one of these from the unit circle like we did before for their respective triangles. Now before I do that, because we're doing these special angles, I'm going to go ahead and, no, I think I'm just going to straight up draw it. Okay, pause. One, two, three. Okay, so what I'm going to do is 30 degrees, remember, is pi over 6. So I'm going to draw essentially the first quadrant. I'm just going to focus on this first quadrant. I'm going to put in my circle, so I'm actually just going to copy, I think, this one. Here. All right, so I'm only going to focus on the first quadrant, and I'm going to go specifically 30 degrees or pi over 6. So this would be located roughly about right here. Here's my terminal point. And again, I know that this angle is 30 degrees, or AKA, this is pi over 6 in terms of radians. And again, I know that this is a radius of 1 because it's a unit circle. So I know this line right here, which is ultimately going to be the hypotenuse, because I can take this and draw it straight down. I'll go across first, and then straight down. And I can form a 30, 60, 90 right triangle, which means if I know the hypotenuse is 1, then I know the scale, and it's the same scale that we were doing yesterday. Across from 30 is 1/2. I'm just struggling today, guys. This is 1/2. And I know the adjacent side would be √3 over 2. I would encourage you to go back and look at the prior video when we had our 30, 60, 90 triangle to see where these sides essentially come from. And if you need some extra help with finding where these come from, let me know, and I'll be more than happy to help you and walk you through that. Now, we know then if I'm trying to find the x and y coordinate for pi over 6 for 30 degrees, remember that the x coordinate is cosine of this angle, and my y coordinate is sine of this angle. Again, this comes from our definitions that we found up here in doing an arbitrary triangle in the first quadrant. And so I can use my triangle to actually figure out, okay, well, cosine of 30 is adjacent over hypotenuse. Well, √3 over 2 divided by 1 is just √3 over 2. For sine, I'm taking the opposite over the hypotenuse, and this is going to be 1/2 over 1, or just 1/2. We also did this yesterday. If you look back, the very last thing we did, I had you go through and find sine, cosine, and tangent for pi over 6 specifically, pi over 4, and pi over 3. And so this is kind of why, so you can kind of see the algebra and see these values. And so just to kind of clarify and close this and kind of give you the conclusion, it's that what we just found here is the coordinate, specifically the x and y value, if you were to travel pi over 6 around the circle. And not only that, if I know the coordinate, then I know what the cosine value is, because cosine is always associated with the x. I also know what the sine value is, because it's the 1/2. So in other words, if I'm tasked with trying to find cosine of a specific angle, if I know the coordinate on the unit circle, then I know the cosine value without even having to draw a triangle. And so this is kind of our goal, is we want to go essentially special angle by special angle and see if we can come up with a coordinate. So then I don't have to continue drawing triangles. If I just know my unit circle, then we can actually find sine and cosine based off of that coordinate. And as a result, we can actually find all 6, again, without having to use triangles as our method. We'll be using the unit circle instead. All right, and I'll highlight this again in part 3. We're going to continue kind of constructing the first quadrant because this is only for pi over 6 right now. All right, so what I'm going to do is I'm going to copy this, just this part. Let's see if I can do a better job. Welcome to the life of an iPad. There we go. Just going to copy this, and I'm going to scroll down. I'm going to paste this down. Okay. And this time what we're going to do is we did 30 degrees. Well, the next angle that's unique would be 45 degrees. That's in the first quadrant. And so for 45, remember this is pi over 4. And so from when we did our circle before, this is going to be dead center between 0 and 90 degrees, or pi over 2. Again, this is a radius of 1, so I can fill that in. This angle that we just rotated was 45 degrees, or pi over 4. And to figure out what this x and y coordinate is, this terminal point here, again, I'm going to draw my triangle. So I'm going to draw this out, draw this down, try to get this to be perfectly at a right angle here. And so notice that the triangle that gets created as a result, again, is a 45, 45, 90. And based on our work from yesterday, we actually know the sides of this triangle when the hypotenuse is 1. This side is root 2 over 2. This side is root 2 over 2. To find the coordinate, notice that this horizontal side here is my x, because that's how many steps to the right I'm going. And this is my vertical, so there's my y. And so we have the terminal point. Now understand that what this is telling us then is that if I want to find sine of pi over 4, then all I need to do is go to the y coordinate on the unit circle at pi over 4, and there's my sine value without actually having to do the triangle. If you look at the triangle that we did end up drawing, then notice this would make sense because sine would be opposite over hypotenuse, which would just be root 2, which is what we got. All right, so here's my terminal points for pi over 4. Now let's go through and do 60. Or pi over 3. So let's see if I can just copy and paste. Boom. There we go. All right, 60 degrees or pi over 6 would be roughly about right here. This angle we just did was 60 or pi over 3. And again, I can draw my triangle because I know this is a radius of 1. I'm trying to figure out what the terminal point is. Draw this straight down. Draw this across. Notice what we form then is a 30, 60, 90 triangle where, let's see, adjacent to 60 is 1/2. Across from 60 is root 3 over 2. Notice these numbers are really similar to 30 because they're part of the same special triangle. And so my x-coordinate is how far to the right, excuse me, how far to the right we're traveling, which is 1/2. And then how far up would be my y-coordinate, which is radical 3 over 2. And now I have my terminal point for pi over 3 on the unit circle. Again, highlighting why this is so important. If I want to find cosine of pi over 3, cosine is the x-coordinate. And so I would get 1/2, and there's my answer for cosine of pi over 3 by looking at the unit circle. Again, we can avoid using right triangles and having to draw a triangle for specifically pi over 3. We can just use the coordinate. Okay, so I'm going to put all of these together now just to make one circle. And this is going to finish off our look in the first quadrant. Okay, so we essentially have here is pi over 4. Here, roughly, Here again was pi over 4. Here is pi over 6. And then to draw in pi over 3, it's roughly about right here. You would think they'd be further apart, but they're actually fairly close together. And then to put in the coordinates that we found, we got that pi over 6 is root 3 over 2, comma 1/2. Pi over 4 was radical 2 over 2, radical 2 over 2. And pi over 3 was 1/2 root 3 over 2. And so these give me the ordered pairs. And again, with sine theta equal to the y coordinate, cosine theta equal to the x coordinate, that x value, then we can actually solve for sine and cosine, and then from here actually be able to do all the other trig ratios. And so this is our first quadrant. We will continue moving around this, looking at this. What happens when we go outside of the first quadrant? That's going to be kind of the big question. And I guess before we end, there are two more angles that are technically a part of the first quadrant that we should look at. Earlier, we were really kind of focusing on angles that ran in between 0 and 90 degrees, or say pi over 2. Well, I'm going to be a little bit more specific. What if we actually allowed for 0 and pi over 2? In other words, what is the ordered pair here, and what is the ordered pair here? As your hint, remember, what is the radius of a unit circle? Well, the radius, remember, is 1 unit. So if I'm here at 0, I haven't gone anywhere yet in terms of rotation, so 0 degrees or 0 radians. This means I've taken 1 step to the right, which gives me a coordinate of 1, 0, because I've taken 1 step to the right, but no steps up or down. And if I go up here to pi over 2, it's the flip of that. I've gone 1 step vertically, but no steps to the right or left. So this ordered pair would be 0, 1. And so if you're paying attention, notice what the implication for this would be in terms of sine and cosine. So the question I'm going to leave you with, and I'm going to answer this a little bit later on, what is sine of 0? What would cosine of pi over 2 be? What about sine of pi over 2? What about cosine of 0? How could I find these values? Because 0 isn't a right triangle. So how can I do opposite over hypotenuse? Cosine of pi over 2 is 90 degrees. That's not necessarily a right triangle. I guess we could find pi over 2 in a right triangle. But if you were to rotate 90 degrees, it's a little bit trickier. And so think about how the unit circle helps me now solve for these. And then we're going to use that idea in the next video as we continue to expand on our unit circle.